Good day, future civil engineers. I am Jericho Diakihaka, one of the reporters of Group 2, and the topic we will be discussing is about building envelope system and assemblies. We firmly believe that the engineering field, various concepts have been introduced that are all playing their pivotal roles and putting the construction into different considerations concerning the structure, the safety, capacity, and other internal and external factors present. This part of the report I will be discussing focuses only on the overview of the topic that will serve best in introducing the concept of building envelope system and assemblies. First, let us define what is building envelope system and assemblies. Building envelope system and assemblies focuses on the application of building science principles to the design of building enclosures. This examines various elements that mediate between the interior and exterior environments, both above and below the ground, in manners appropriate to their intended function and performance. Case studies of building enclosures and their components illustrate the importance of having a comprehensive understanding of building materials and building processes. Wall sections and other building details are used to identify strategies to achieve sustainable and high-performance buildings in various climates. We all know for a fact that humans first created shelters to provide thermal comfort and protection from natural elements. And still, this remains a primary objective of buildings. To understand further, let us define what is building envelope. Building envelope is a structural barrier between the interior and exterior of a building. It is responsible for maintaining climate control within the interior of a building. Climate control refers to the cooling and heating of a building. The building envelope keeps the interior free from moisture, sound, and light. The building envelope structures includes roof, walls, foundations, doors, and windows. The building envelope is the physical separator between the interior and exterior of a building. Components of the envelope are typically walls, floors, roofs, fenestrations, and doors. Fenestrations are any opening in the structure, such as window, skylights, clerestories, and etc. When designing the building envelope, knowing some fundamental building materials and heat transfer will help us make the right trade-off decision. Significantly, we have to take note that a well-designed envelope responds to the local climate, meaning climate is one of the major considerations in building envelope. The summary below shows 4 common extremes that people design for. First is the arid climate envelope. We all know that arid climates are very dry and usually hot, but they often have large swings of temperature from day to night. Thus, thermal mass on the outside of the building is the most crucial design strategy to even out such temperature swings. For consistently hot locations, it is also helps to have high ceilings, shaded breezeways, light colors, and daylighting via reflected light. And you have to take note that that is not direct sunlight. Second, we have the tropical climate envelope. When we say tropical climates, we are thinking that it is hot and humid. Therefore, keeping the heat of the sun off is a top priority, as well as maximizing ventilation. Most of the tropical climate buildings, or primarily houses, have thick light-colored thatch roofs that keeps out the sun's heat, while There are open eaves and porous bamboo slats for walls and floor that maximize natural ventilation. The materials are all low mass to avoid condensation and mold growth, which can happen within high mass materials and humid climates. Third, we have cold climate envelope. Considering that cold climates have many more heating degrees than cooling degree days, maximizing insulation is the key to keeping warm, as well as using windows for solar gain on thermal mass inside the building envelope. This is very unlikely to arid climates. Part of having effective insulation in cold is an airtight envelope avoiding infiltration. To maximize solar gain while minimize losses elsewhere. Before modern insulation, thick solid log walls such as these provided better insulation than board walls could. Next, we have the mixed cold or hot climate envelope. So this is the last of the building envelopes for climate types. Many temperate inland climates actually have two extremes, such as cold in winter, hot and humid in summer. Flexibility is the key to design for these climates. In this type of climate envelope, most use deep overhangs to allow low winter sun in through the windows to heat up a high mass concrete slab, while it is blocking high summer sun. It also uses light roof and darker walls to repel summer sun but also absorb winter sun. Extra insulation retains heat in winter, but operable windows passively cool it in summer. What we can conceive regarding this matter is that these parts are separating what is inside of a building or the interior and what is outside of such structure, which is exterior. Take note that in the definition itself, it can be understood that the envelope serves as an enclosure, such that it should be designed as a mediator from the internal and external environment, as it could affect a certain structure, more specifically, climate conditions. At the end of this report, we will be able to understand some of the major concepts undermined by the building envelope system and assemblies, which includes fundamentals of performance, aesthetics, moisture transfer, durability, and energy and material resources. And that concludes my presentation.